Hello everyone. In this video, I will walk you through the AML project on mental health self-analysis. The goal of this project is to predict whether a person might need mental health support based on their responses to the survey. I have implemented this using machine learning and built an interactive user interface for easy predictions. So, let's get started. So, this is a Google Colab platform in which we have started this model training. So for the model training, we have taken survey.csv. Actually, this is the data set for the mental health analysis in the tech survey. So this survey.csv is this data set in which it is having a lot of constraints like instances like timestamp, age, gender, country, state, self-employed, all these details it is having. So in order to use this survey.csv, I have uploaded this file here. And now as it is a CSV file, I have used read CSV to read this file. And whenever we got the data set information, the first and foremost thing is we need to clean the data. So in order to clean the data, we have checked whether there is any missing values or not. So I have used this and you can see this is the output. These are all the instances that are there in the dataset, and these are the missing values. These are the missing values. So in the next step, we just dropped out the timestamp and the state because we can, in order to pre-process the data, it is must and should that we should always have the only relevant information. So as this timestamp and state are irrelevant, I just wanted to drop this, so I use this. And the next thing is categoryless thing. So I have used, as I told you that in the previous session we have seen the missing values. So now I am trying to fill the missing values with their medians. So that is what I have done here. And in the next step, we have started the pre-processing using label encoder. And we have also saw the count plot for mental health treatment distribution. So you can see the mental health treatment distribution is drawn between count and the treatment. As you can see, it is showing 0 and 1. So it is a binary classification. So 0 means whether he needs any support or not. 1 means he needs definitely a support. And we have also come up with the correlation matrix. The correlation matrix, you can see this is the correlation matrix, and these are all the instances that are there in our CSV file. Next step and first foremost step, very important step in any model training is what are the features that we are going to select. So for that I have used a random forest classifier. By using this random forest classifier, we can see what are the important features that plays a crucial role in order to predict the output. I have strictly mentioned it to 10. Next, as we have selected the 10 features from this data set, we need to know their importance, like what amount of role they are playing in predicting the output. So that's why I again used a random forest classifier and we have calculated it. So we got these values. So we just needed to know the sort the features by the importance. And I told you it is a binary classification between 0 and 1. So we have seen here 0 and 1 classification is there. Whenever we got any dataset, we need to split the dataset into the trained dataset and testing dataset. So that's what I have did here. The training dataset and the testing dataset is split. And then we have used the SHAP. So the SHAP is used here to make the model's decision interpretable. I use the SHAP. This method helps us understand which features contribute most to the predictions. For example, here we have taken two features, age and work interface. So you can see this is the SHAP analysis which we have did. And now coming to, as we have completed the pre-processing, the next step is training. For training, we can't solely rely on any of the model. So first I have taken the random forest classifier. So I have used the random forest and I started predicting it. So I got the F1 score as 0.75. And then I have taken XGB classifier as another model. As in the assignment, it is mentioned that we have to compare the models. So this is the second model. And here also we have derived the scores. So you can see the F1 score for using XGB booster is 0.67. So here is the code for the comparison. I have compared the scores, F1 scores of the boost, random forest accuracy and XGB accuracy. We got 0.7500 and 0.6. So we can clearly see that random forest accuracy is more than the XG boost accuracy. So I have chosen random forest. As I chose random forest, now I need to train the model in the random forest. So again I used random forest classifier and I did training. So the final model performance has done, and we can see the F1 scores is 0.75, and finally the model was saved. So this is all about the model training. So as we have trained the model, we got the mental health model.pkl in which the trained model is saved. So now we can use this trained model in interfacing CLI or the UI. So let us see the CLI. So this is the code for the predict using CLI.py. So we have loaded that mental health model, which is the saved model, and we know that we are having the final features as all these things. So as it is only the testing using CLI, I haven't mentioned a lot of options here. You can see the most options in the UI, as it will be very user friendly to understand. So we have predicted the data using predict data, and you can see whether the prediction comes as 1 as an output. That means we should that the user should consider speaking to the mental health professional. It is showing that the mental health of the user. And if it comes as 0, then you seems perfect, it's all right to the user. So all this prediction is made up of the how the user answered the questions in the set. So let me show you how it works. So as we have saved the predict using cli.py, and we should also use mental health model.pkl, we should make sure that these two things should be in the same direction. And now we can go into the terminal or command prompt, and we need to run this CLI. So here we can see As we went in command terminal to run it, we can see it as it is using CLI. It is asking the questions work interference. You will get to know what are these 1 and 2 in the user interface clearly. There it has mentioned actually what does 102 all this kind are means. As of now, you can understood that 1 and 0, like 1 means yes, 0 means no. So you can see if based on all the inputs which I have entered, it is predicting it predicted my mental health, like needs mental health support, and it also given the scores 0.25 and 0.75. 0.25 is for whether you are good in good condition, 0.7 means 75 means you are in the bad condition. So this is our output using CLI. As we have seen the prediction using CLI, now let us see the prediction using UI. Like you can see the user interface here. So this is the mental health underscore UI, in which again I have loaded the same thing like trained model into my code. Then these are all the user interface code. You can see like styles and H4, all these things. So here comes our options. What are the inputs that we should take? We should take the inputs from the users as of our selected features. During training, what are the features that we have selected? We should take the user inputs for that features. So you can see work interface options. As I told you, while we are testing through CLI, I said 0 means something, 1 means something. So here you can see because I have added drop down values here. So you can see what does 0 means, what does 1 means, 2. Family history options, no means 0, yes means 1. Gender options, male is 1, female is 2. Country options, number of employees, 1 means it's a range in between 1 to 5, 2 means range of 6 to 25. Leave options, 0. Benefits mental. So these are all the options, and in the UI I have added the drop down in which so that user can understand what is actually 0 and 1 means. And these are the code for the UI drop downs. And I have created a data frame for this. You can see for the columns. And here you can see we started prediction based on the user values. If the prediction comes as 1, then that means consider speaking to the professional. That means the user health is mental health is not so good. If it comes as 0, then it will you seems correct. Like user health is alright. And then it is developed by us. So this is the user interface. Let us see how actually it is. I'm using Streamlit, so that's why I have to use it. And when we do it from the command terminal, you can see the localhost. So this is the whole interface. Mental health condition predictor, a machine learning tool, and this thing. Here, this is the result part. This is the input features. So the user has to in give inputs of for the all features. So the work interface. You can see never means 0, rarely 1, sometimes 2, and often 3. Let us give some random values and let us see how actually our model is taking the values. Care, gender, country, company size. It tells about the range of employees in company. Workplace. This company and workplace benefits are added because we have taken the data set for the mental health in the tech survey for the people in tech. So after giving all the inputs here, we can go here and we can say predict mental health condition. So based on all the inputs which we have given, it is saying that you needs mental health support. The prediction confidence is no major concerns is just 31% and needs mental health support is 69%. As you can see, there's a lot of difference between no major concerns and need mental health. So it says that user needs mental health based on the inputs. So this is the thing, this is the model which we have developed, and this is the UI which I have developed using Streamlit. So this concludes my project demonstration. In summary, I built a mental health prediction model, compared multiple models for the machine learning models, and developed an interactive UI for predictions. In the future, I plan to improve my model by experimenting with the LLM based explanation system. Thank you for watching. If you have any questions, feel free to reach out. Thank you.